This is a short introduction video on the time value of money, in particular the present value. My name is Þórður Víkingur. What is the time value of money? Perhaps it is a good starting point to ask a question. Would you rather have 100 euro today or 200 euro in the future? And probably you wouldn't be able to answer that question because there are many things to consider. For example, how many years are we talking about? Before I receive the 200 euros. How much inflation? Inflation reduces the buying power of money of the future. I could take the 100 euros and put it into a bank. What rates would a bank give me? Are there other opportunities, etc.? So there are a lot of things to consider before answering it. The future value of money decides the worth of money you receive. If you, for example, put money in the bank on a certain rates, you can figure out the future value by taking the amount, in this case, the 100 euros from the case previously mentioned, and multiply it by the 1 plus the rates. And the power of 1 refers to 1 year. Usually those calculations are made in the end of the year. If we have 100 euros for 2 years in the bank, then we multiply it by 1 plus the rates in the power of 2, and for 3 years for the power of 3, etc. The rates, or the discount factor as it often is called, gives a subject for discussions. In many cases, we're not talking about bank rates directly. There are other things to consider, but that's outside the scope of this lecture. But for example, the risk, the inflation, many other things would have to be considered and taken into the account when deciding the discount factor. But in our case, it's a constant. It's something that is predefined, so you don't have to worry about that. Time value of money, the present value, is perhaps of more interest in context of the case. The present value is the 200 euros in the previous example, and we have to divide it by the 1 plus the rates. In the power of 1 refers, of course, to the 1 year, and the present value for 2 years is then in the power of 2, and for 3 years in power of 3, etc. So what happens is that we have to reduce the number, for example, the year 3, by the rates. That obviously reduces the present buying power of that 200 euros. If we have something called a net present value, which is a very common financial calculation in all investment projects, we would take the sum because we have periods, we might have many years. So we take the future cash flow of each period, and it's called the net present value because we have to subtract the investment that we make as the initial investment usually. So that's the net present value of a future cash flow minus the initial investment. So the question, would you rather have a 100 now or 200 in 5 years if the discount factor is 15%, is answered by taking the 200 euros and dividing it with 1 plus 15%, the rates, in the power of 5. And you can see that's a smaller number than the 100 euros, so you should say no. I'm going to take the 100 euros right now. If the time value of money comes in different periods, we could rephrase the question. Would you rather have a 100 euro now or 50 euros after 2 years, and then 150 euros after 4 years? And are you still using the discount factor of 15%? Then you would find the present value by taking the sum of the 50, 1 plus 15% to the power of 2, referring to the 2 years, plus the 150, and that would be discounted by the 1 plus 15%. in the power of 4, and that gives us 123 euros. So it seems like a better deal in monetary context.